Hey guys, this particular video goes over um, basically what a function is and then how we graph it to see what kind of picture it creates. So I'm going to go through three examples, and at any time you can fast forward, pause. So if I do or say something and it doesn't make sense, you can always rewind it. But I'm going to go through basically what it means to be a function and then how we graph it. So over here in the corner, I have y equals negative 2x plus 4. So this is a function, which in other words is an input-output machine. So x is the input, y is the output. So if we want to draw a picture of this and figure out what it looks like, we need some input and output values before we can graph it. Now notice no input values are given. So this is where you get to choose the input values that go into the function. So pick really easy numbers. Try not to go over 5, just because if the numbers are too high, then they start to go off the graph. I would always suggest plugging in 0. 0 is always a good one. And again, anything that's around 0 to keep your numbers small. So 0, 1, I'll do 2, and then maybe let's do 3. So we'll put 3 in and we'll see if that fits on the graph. So you basically just pick 4 inputs. 4 inputs are good, 3 are okay, but 4 is better because then you'll actually see or catch any mistakes that might happen when you're doing the math. So here's how this works. 0 goes into the function where the x is located. So I'm basically doing negative 2 times 0 plus 4. And then whatever the answer is my output, also known as the y. So I do negative 2 times 0, which is 0, and then 0 plus 4 is 4. So the number goes in, do the math, y is the answer that comes out. So we'll go ahead and fill in the chart the same way. Negative 2 times 1 is negative 2 plus 4 is positive 2. And again, you can use a calculator to check my numbers. So if you're not sure where I'm getting them, just use the calculator. So the next one, negative 2 times 2 is negative 4 plus 4 is 0. Negative 2 times 3 is negative 6 plus 4 is negative 2. So once I have some inputs and outputs, these are basically my ordered pairs. So this tells me where to go over here on the graph to plot a point. So this is 0, comma 4. So 0, comma 4 would be right here, and I put a point. So I'll just put an X because that's easier. 1, comma 2. So I'm like, okay, 1 over up 2. There's my next point. So what should start to happen, so when I plot the next point to 0, that means I go 2 to the right, stay at 0 on the y. I should start to see a pattern that creates a straight line. So 3, negative 2, just to graph the last point. And then I start to see this line. So all the graphs that we do in 8th grade should be straight lines. So if you get a weird zigzaggy pattern or like a check mark, then you have to check two things. You have to check to make sure your math was right and that you graphed it correctly. So there's really two places where the mistakes could happen, the math and then the actual graphing of the line. So this line right here is a picture of this function. So it's a matter of plugging something in, getting something out, and then plotting the points. So I'm going to do a couple more examples just to make sure that particularly when input values aren't given, that we can kind of figure out how this goes. Actually, I'm going to just show you one more example, just because this is a basic idea of input output. So let's do this one. Oops, too far. So this function is 1/2 x plus 1. So again, no input values are given, so we choose them. We get to control what goes into this function. So again, 0 is always a good one, no matter what's going on in the function. So I would always suggest that one. Now, one of the things I notice is whatever input goes in is going to be cut in half. In other words, that's what that half means. So I have to take half of the number that goes in. So if I'm controlling the inputs, I'm going to choose numbers that are easy to cut in half. In other words, that don't give me decimal answers, because I don't want to have to graph a decimal. You can, but if you choose inputs, I would choose to make it easy. So I'm going to pick a number like 2. Let's do 4. And then just for the fun of it, I'm going to do a negative 2. just again to have 4 input values and to make sure that it stays on my graph. So I do 1/2 times 0, which is 0, plus 1 is 1. 1/2 times 2, so half of 2 is 1, plus 1 is 2. Half of 4 is 2, plus 1 is 3. Half of -2 is -1, and then -1 plus 1 is 0. So this table tells me what my ordered pairs are going to be. So 0, 1, 0, 1, right here. 2, 2, so right 2 up 2. 4, 3, right 4 up 3. And then -2, 0. So I go left and then I stay. So again, you can start to see where the line appears. This graph right here is the picture of this function. So again, if you get any weird zigzaggy patterns, check your math, then just make sure you've graphed correctly. Everything we do should be a straight line. So a couple things to keep in mind. If they don't give you inputs, you choose them. I would always pick zeros. Zero is always a good one. And then you can pick any other numbers you want to use. Just make sure that they stay on the graph and don't go too far off. If they go too far off, you probably need to pick like just a different number so that it shows up on the graph. So that's basically how you graph a function using inputs and outputs.